Hello everybody, I'm a Rainbow. This video is a little bit outside of the things that I normally post, dealing with the Oculus and gaming and computer help, things like that. However, it is within the realm of things that I do. I am an electronics technician by trade. The Air Force spent a lot of time teaching me how to troubleshoot and repair advanced weapon systems, and an HVAC or a furnace repair is not really that complicated. Now, when I had the opportunity to troubleshoot and repair a unit, I figured, hey, let me go ahead and record it because I thought it would be helpful. This deals specifically with the Trane XR80 furnace, but I'm going to walk through all the steps that would apply to almost any gas-fired furnace and can help you out. So if you have specific questions, hit me up in the comments. Hit me up on Discord. I'll be happy to try and help you if I can. And let's jump in and get this thing repaired.
This is the Trane XR80. This is what it looks like. If you have one, you'll be familiar with it. It says it right there on the front. I am going to open up the lower panel, which is where the gas ignites. There is no safety switch or anything there, so we can see what's going on and you can get an idea of what's happening. We're also going to start our troubleshooting in this area. All right, let's take a look and see what this thing is doing.
That noise is almost a dead giveaway. It's a fan trying to start up. I'm not having any luck. Everything else is running. All right, the unit just shut down. The gas just stopped.
Based on what I've seen and heard, I believe I have a good idea of what's going on and what the problem is. But I am going to run through all the different sensors and troubleshoot this thing just to make sure it's not something else. As I do that, I'm going to bring up the schematic. I'll show you the item that I'm looking at and what I'm talking about so you've got an idea how these things fit together. The vent motor is running, doesn't seem to be an issue. It's not stuttering, not doing anything funny. I believe it is fine. The gas valve or the gas regulator, the gas comes out just fine. It's not stuttering, not doing anything funny. I believe that is fine as well. If you suspect you have a problem with your gas valve, please get somebody that's qualified to look at it. Don't do it yourself. When the vent motor comes on, the pressure sensor is activated, and if it was not, then everything would shut down immediately. I do not believe there's a problem with the pressure sensor at this time. You have two thermal cutouts. One is there where the heat is generated. The other is up by the blower motor. I believe the one or both is being tripped right now because of something, but I do not believe they are bad. I believe they're working the way they're supposed to. Next, you have the flame sensor. It literally sticks in the flame and is supposed to shut things down if it does not sense any flame when there should be gas on. Next, you have two flame rollout sensors. Basically, if flame comes shooting out of the box, those are supposed to activate. That's obviously not happening, so I believe both of those are fine. The last component that could be giving you a problem is the hot surface igniter or the igniter. We saw that come on and ignite the gas. I do not believe there's any problem with the igniter. It actually shuts itself. It shuts down after the gas comes on. So I believe there's no problem with that, but we will walk through any of these things that we can check?
If your gas is coming on, everything's spinning out, but it's not igniting, it's probably your igniter. That's this guy right here. Now, you can verify with most igniters by ohming them out. You need a multimeter. You can also just observe typically when it's running to see if the thing gets hot.
The igniter is that glowing piece there in the back. You'll see it get red hot, and then the gas will inject and ignite. That's how it's supposed to work.
And you want to ohm it out and make sure it reads a resistance. So that is a short. If it was not reading correctly, it would be something like that. So if it shorts out, that's good. It means it's reading across the igniter. The igniter should be working. If the igniter is not working, it's usually a simple fix. You can get a replacement. They have all kinds of replacements. And in this case, it's just take out those 2 screws, pull the igniter out. Matter of fact, I'll just go ahead and do it.
There are 2 very common failures in furnaces. One is dirty filters, and the other is igniters. Because they get so hot, they tend to break or burn out over time. It's usually the first thing that goes on any furnace. So if you suspect an issue and you don't see your igniter lighting up, that is probably the first thing to check, and it's also a very cheap repair.
That's what your igniter looks like. $10 at Amazon. This one's fine. We can go ahead and put it back in. All right, this is a flame sensor right here. That's what that looks like. So you can clean these up with a little bit of steel wool and it should be fine. I don't believe this was a problem, but we're going to go ahead and clean it up. All right, you can take that. I don't have any steel wool, but I'm just going to.
I'm going to go ahead and pull this thermal cutout sensor and show you how to check it. It is a normally closed device, so ohming through it, you should be able to tell it's working right off the bat. Now, I believe this sensor is what is actually shutting down the unit, but it's not because the sensor it's bad. It's doing its job, and I believe it's getting too hot because there's no airflow because the fan's not rolling. Time will tell, but I believe that's the case. And when we ohm this out, we'll find out it should be a short across it, which is what it does. And when it gets too hot, it opens up. The thermal cutout sensor is a normally closed device, so if you ohm from each side of it, it should read a short. If it's cool and it reads high resistance or an open, then it's bad. In this case, it's fine.
so I believe all of this is working like it's supposed to. And I have not heard the actual indoor fan working at all. I heard it making noise, trying to spin. It's not working. So it is behind this panel right here. So we have to get this panel open to get to the fan. Now, with the fan, it's usually the fan motor itself or the capacitor. More often than not, it's the capacitor. And hopefully it's accessible right here when I get this panel open. But to get this panel open, I have to take this off.
To get this off, I have to take the exhaust blower off.
So, be careful taking this off. You don't want to impact this guy right here. All right, now this guy has to come off. I've already taken the screws out. Oh. I'm not going to mess with the electrical panel. I just want to get this open. Ooh, it's going to get in my way. If I can manage it.
My initial plan was to not pull the electronics and just open that panel up so I could get access to the capacitor and maybe look at the motor, but I was unable to do that. So I went ahead and used my trusty cell phone there to take some good pictures so I know where all the wires are, and then I proceeded to disconnect them. And make sure you get good pictures so you can refer back to them. I definitely needed them when I reassembled. I had to take some channel locks on this last connector down there at the bottom because it was flat out stuck.
Was it stuck on there? Wow.
On this last bit, to get the wiring out, there's a rubber grommet there. You kind of have to pull that out, and then there's a slot cut in the sheet metal that everything else slides in and out. And this one thing I'm messing with right here is the other thermal cutoff in the system. I just checked the wires on it just to make sure they were good, and they seemed like they were fine. I didn't think this was a problem, but better safe than sorry. Now I'm going to check out the blower motor and the capacitor. I'll check out the capacitor first. I'm hoping the capacitor is just bad. It's very simple to replace, even though it takes a bit to dig out.
Alright, so check the capacitor. We want to be in ohms. We want to be in ohms. Something high, doesn't matter. Now, polarity can matter, but we'll just see if it's charging or discharging at all. Now, that capacitor appears to be working, which is what I was hoping was going to be the problem, because that's the easy part. Alright, so I've checked the capacitor. It appears to be working like it's supposed to. I'm not worried about the sensor on the fan. It sounds like when the motor running before, this is the thing I thought was the problem, because it sounds like the motor just wasn't running. And so what I've done is, the only real way to check it is to get power on it, unless it's just froze up, which doesn't happen very often. So I have taken the input power from here. One of them goes straight to the safety switch, which I've disconnected, but you need the black and the white wires from the motor. Your motor might be different, but this was the stock motor that's in here. The black and the white ones are power and return. So I've hooked those up, and I jumped the one hot wire coming in at 120 and just have a jumper on it. Not the best jumper in the world, but I'm just doing this for a short term, and I've got it running through a switch, so I can press the switch and get power to the motor. Here we go. That's the same sound I was getting before. Was not getting anything, so the motor is not engaging. The motor is bad. You can try rotating a little bit. You might find, don't do it when there's power in it or when this thing's running. You can try spinning a little bit. So, and it's possible that capacitor is working, but it's not working the way it's supposed to. Capacitor's $10. The motor's probably 100. I'm going to start with the order and the capacitor, get that in, swap that out, and then I will come back to the motor. I'll probably go ahead and order the motor anyway, just to save time. But that's where I'm at right now. And since I'm going to leave the unit in the condition it is, wires disconnected, I'll pull the power off so it's not going anywhere. You want to turn the power off, flip a circuit breaker if you have one. In this case, I have a fuse. I'm pulling the fuse, and I will also tag it out. Nobody else is going to be messing with this but me, but it's better safe than sorry. Always tag out your electronics if you don't want anybody messing with them, because right now they'd have to take 2 distinct actions just to turn power back on before they could electrocute themselves. So they'd have to be working pretty hard to do that. They're not just going to flip a switch and bad things will happen. Alrighty. Alright, I'm removing this unit right here. I disconnected all the wiring to it. It looks like it just slides out. There's a screw or a bolt right here and a bolt right there. Once I get both of those out, it should just slide. There's a lot of sheet metal there, a lot of edges. I would suggest wearing some gloves, but hey, it's up to you. Let's see how hard this is to pull out. Oh, it wasn't too bad. little flange right here that wants to catch. Not right there, so watch yourself. Other than that, pretty much came right out. It's probably 30 pounds. There's a shaft right here that comes through. We need to undo these so that the disc controls it, how it hooks right there. We'll disconnect those two, then I'll pull the motor from the other side. It looks to me like there's a bracket here. I don't think I have to take it all off. I believe I can take off this back piece and just drop it back in. We will find out in a second. There's 3 attachments right there. I'm going to do that. Hopefully this will just come out. And this is a 1/4. Nope, 5/16. 5/16. All right, so it's also attached down here as part of this bracket. Much simpler. I should have done that on the first one. Oh, the whole thing came loose. Up there it comes. All right. Lube would have been some helpful. If I had some WD-40, I may need to still go get some of that. Up there it comes. All right, get this out of here. I got to get those 3 screws. The brackets just come top and bottom. All right. Engine shafts, those are both the same. Height, the same. Back's a little different. I wonder if this is. Gave me one. Actually gave me 2. That is in the back there. I have 7 here. I have no idea what these 2 are for. I'm going to assume that since they're together, they're supposed to stay together. That other one came off. Something to set that on. I'm just going to kind of set it up in there and set it on that ring on the other side. Seems like a good enough spot. And so you can see where their flat spaces are for each side. There's only one of those that you dig into. So I just need to catch one of those two spaces, either this one or this one, with the motor. Alright, and the orientation of the other one, the wiring was along this side here, and I'm leaving it that way. And then we got this, oh, I'm going to have to attach that. Oh shit, I best do that first. Alright, I've got that in, I've got those oriented, and now we're going to get them installed. Cool. Alright, so that shaft, we don't want it too far to one side or too far to the other. I'm going to try and tighten it up in there, and I will spin it to see if it's binding up or if it's making any noise. Ideally, I'm going to guess it's somewhere in the middle of the two. We'll have to see how well I can manage that. Seems like it's good. I've got plenty of clearance on both sides. Let's see. Alright, you see this side is much closer than that one. I'm going to go ahead and slide it back just a little bit more, just in case if it develops a wobble, something like that, then I don't have to worry about that. And they were really hard to break. You don't want them coming loose. It'll just rip itself to shreds. So make sure you get it in there good. All right. So now, if you can see, it's fairly uniform on both sides. I'm happy with that. Seems to spin freely enough. So I think we're ready to put this bad boy back in and give it a test. Alright, goes in the same way it came out. If you can see, there's these two little flanges. That's got a slider. There's two on each side, and we just need to get it in there. So this bundle of wires right here, especially these little short ones that are jumped to each other, I'm going to leave, but I want to make sure they don't get caught up in the motor at all. So I don't have a zip tie with me, but I do have a piece of solid core wire, so I'm going to make sure that those are strapped around that same bracket so they can't get caught up or sucked in or anything like that. All right, you saw when we were troubleshooting that the cap seemed to be fine, but since I had to dig into this and get there, I'm going to go ahead and replace it with a new one. There's no point not to. This one's a little bit smaller than this, but this was what they recommended for the motor, and we'll find out in just a second. We're just going to connect those two terminals together. We'll let it sit right there. And then remember, we have to jump the white wire for the power coming in. See if I find it. All right, if this is working the way it's supposed to, that motor should start up and we should all be good. Now, there's the moment of truth. Let's try it. Oh, brilliant! Yes! So, always feels good. It's running good. The air's blowing. I'm happy. This is great. So you always feel really good. You're pretty sure you know what it is, and you say, oh, it's got to be that, and then you get to the end and you go, but troubleshooting wins out. So we got it in, we swapped the motor. We want to listen to see if we hear anything wrong with it. It sounds fine. I'm going to let it run for a minute or two. All right, we're going to get it all back together now. So I'm going to get that cap hooked up first thing. That's in there. That's not going anywhere. Let's see about tucking those wires around some more. All right, I've disconnected the power from there. We're pulling the jumper out from the power. Now we got to get this mess all hooked back up again. I just tucked those because the wires are long and I want them out of the way. I don't want to get them sucked up in the air. All right, let's see if we can manage this craziness. Truthfully, I think this is an overkill. And I'm just going to drop that off of there because I don't really need it. And I'm just going to put those together like that. Because I don't need that extra interlock right there. It's just mechanically, especially since I'm probably the only one ever going to dig back into this thing. All right. Let's keep going. There we go. That's a better picture. All right, I've got all the wires back together. Should be ready to go. Now I can get the blower put back on, the vent back on, and it should be ready to give it a test at that point. I'm going to put this on so it holds the switch. I am going to leave this open for now. Oh, that's a good sign. All right, so the fan's running. Everything else is looks like it's working like it's supposed to. So we got to give it a couple minutes and find out if we get the overheat, which we were having before. But I believe that the motor's running. Matter of fact, I can hear it. Not hear it, I can feel it. You put your hands on it, you can feel that fan vibrate. All right, everybody, the furnace repair is done. It's working good, heat's coming out of it, and I spent roughly 3 hours of my time on it and 270-ish bucks. Most of that was the ordering the blower motor, another $10 for the cap. Easy peasy. Hopefully this tutorial will help you out in the future. If you've got questions, please hit me up in the comments. Hit me up via Discord. I'm happy to answer questions. Do what I can to help. Y'all be good. Rainbow out.